Okay, so here we have lesson 7. So now we're starting to look at transformation of trigonometric functions. So really this fits the rules of every other transformation that we talked about throughout the course. We just have some special terminology we use when we're talking about sine and cosine functions. Now, the curriculum is very specific in that it says we need to look at transformations of sine functions and cosine functions. The workbook occasionally does a transformations of tangent functions, which is not in the curriculum. So if we come across those examples, we're going to skip them. So we have the equation y equals sine of b of x minus c, close bracket, plus d. This is on your formula sheet. I believe only the sine one is on your formula sheet, not the cosine one. But really, they're very similar. Sorry, oh no, they are both on there. They're at the very bottom of your formula sheet. So both of these are on there. So use the knowledge gained from the transformations unit to describe how the graph of the given function compares to the graph of y equals sine of x. Well, here we have a 2 in front of sine. So this would be the same as having this. If we wanted to, we could write it either way. So this means we replaced y with 1/2 y, if you want to think of it as a replacement. Or you can say, well, we're multiplying sine of x by 2, so we're multiplying the outputs of our original function by 2. Either way, we're going to describe this as a vertical stretch by a factor of 1/2. And we can always add about the x-axis because it's changing the distance from the x-axis. What if the 2 is next to the x instead? So remember, there's really going to be brackets here. Really now we're having an input of 2x instead of x. So what this means is we have a horizontal stretch by 1/2. So when we're talking replacement, we do need to take the reciprocal of that value. So we replaced x with 2x, which means our horizontal stretch about the x-axis is by a factor of 2. If we go back to the first example here, when we replace y with 1/2 y, it's also a vertical stretch by 2. But here, since the 2 can be also written on the opposite side, sometimes we forget that we really are taking the reciprocal there as well. Next one, y equals -3 sine x. So this is again a vertical stretch by 3. And that negative sign, just like in our transformation unit, is a reflection. It's multiplying the y values by -1. So this is a reflection in the x-axis. The last one, well, what if we have the -3 in the input? This is a horizontal stretch by 1/3. And we're multiplying all the x values by a negative, so this is a reflection in the y-axis. B, in which of the above examples is there a change in amplitude compared to the graph of y equals sine of x? So remember, our amplitude is this. So we're going to get a change in amplitude when we multiply our y values by something, because that's going to give us a vertical stretch and give graphs like that. Or, of course, graphs can get smaller as well. So this would be 1 and 3, where there are vertical stretches. In which of the above example is there a change in period compared to y equals sine of x? So a change in period means we multiply x values. So it's simplest if you think about these x-intercepts. If we have a horizontal stretch of 1/2, this x-intercept is now half the distance away. So our graph is going to be compressed or be made skinnier. So the ones with the horizontal stretch are going to change the period. So that would be 2 and 4. So complete the table, use a graphing calculator if necessary. So we know that the graph of sine of x, we know, has an amplitude of 1 and a period of 360 degrees. You could, of course, work in radians as well, but we'll just work in degrees for now. 2, so now we're multiplying our y values by 2. So our amplitude is going to be twice as much. Instead of having a maximum value of 1, we're going to have a maximum value of 2. There's been no horizontal stretch, so the period's still 360. Y equals the sine of 2x. So now we have no vertical stretch, so our amplitude is still 1. But now we've multiplied all of our x values by 1/2. So that means our period, we start to repeat the cycle in half the amount of time. So our period will be 180 degrees. Y equals -3 sine x. Our amplitude will be 3 because our maximum point will change from being 1 to being 3. Similarly with our minimum point, it goes from -1 to -3. We have no horizontal stretch, so the period is 360. We have y. Notice how the sine or reflection doesn't change the amplitude of the period. It does change the look of the graph, of course, but it doesn't change the amplitude of the period. So sine of -3x, the amplitude is still 1. Now we're going to be repeating our function in 1/3 of the time because we have a horizontal stretch of 1/3. Or we're going to repeat 3 times faster than we did before. So our period would be 120 degrees. If you need to graph that and see it, that's fine too. 5 sine 4x has an amplitude of 4. We're now going to repeat in 1/4 of the time. Well, 1/4 of 360 is 90 degrees. Keep going. 1/3. We now have an amplitude of 1/3. We times our max and our min by 1/3. Now, since we have a horizontal stretch of 2, it's going to take us twice as long to repeat. So instead of repeating in 360 degrees, it's going to be in 720 degrees. And how does this relate to any value we have here? Our amplitude, we say, is the absolute value of A. We never talk about a negative amplitude, so that's why we put absolute value. The period is 360 divided by the absolute value of B. Now the B is the number in the equation, not the stretch factor. So for example here, our B value is 4. 360 divided by 4 gives us 90. So we take the B value right from the equation. We don't take the reciprocal of it to find out our period using this formula. Okay, so he says, what should expect similar effects on the graph of y equals a cos b of x? Well, yes, it's the same thing. Our intercepts are in a different place, but other than that, the graphs are identical. They're just shifted over. It's the same thing will result. So here's just a quick summary. Changing the parameter a on the graphs of y equals a sine x and y equals a cos x results in a vertical stretch about the x-axis with the following. If a is greater than 0, it's just a vertical stretch. If a is less than 0, there is a reflection as well as the stretch. Changing the parameter of a on the graph y equals a tan x also results in a vertical stretch of a. Again, we don't need to work on transformations of tangent graphs. Changing the parameter b on the graph of sine, cos, or tan, even though we're not concerned about it, results in a horizontal stretch about the y-axis with the following. If b is greater than 0, the result is a horizontal stretch of factor 1 over b. If it's less than 0, the result is a reflection of the y-axis of a horizontal stretch of factor 1 over the absolute value of b. So here are our guidelines. These are not on your formula sheet, and they're something that I think most people do best if they just remember them. So the amplitude is the absolute value of a, or you can always think of it as your max minus min divided by 2. The period of a sine or cosine graph in degrees is 360 divided by b. And again, it's the absolute value because we never talk about a negative period. Same thing in radians, it's 2 pi divided by the absolute value of b. The tangent graph has a different period. We should know what the period of the tangent graph is, but we don't need to worry about transformations today. Hints for graphing a function manually. So if you have to graph it without a calculator, sketch the primary trigonometric graph. Adjust the basic graph for any change in amplitude by considering the max and min points. Adjust the new graph for any change in period by dividing the period into 4 parts using the maximum and minimum points. So consider the graph y equals 4 times the cos of 2x between 0 and 2 pi. So we're only going to graph this between 0 and 2 pi. We know it goes on forever, but we're just going to do one section of it here. So state the amplitude. Well, the amplitude is 4. The period, it wants us to graph between 0 and 2 pi, so we're going to work in radians for this question. Is 2 pi over 2, which is our b value. So the period is pi radians. Sketch the graph on the grid using the graphing calculator to verify. So what's important to remember is which graph we're starting with. So here we're starting with a cosine graph, which usually has a max of 1, and it usually has this point 1, 0 on there. But we have an amplitude of 4, so this point is now 4, 0. It's always easiest to start with that point, as your x value is 0, so the horizontal stretch doesn't affect it. And then you have a few different ways you can think about this. You can say, well, I know the period is pi, so that means at pi, I'm going to get to that exact same height, because I'm going to have to get back to where I started to repeat it. And then I also need to find out where my minimum value is going to be and where the intercepts are going to be. Well, my minimum value is going to be at -4, and it has to be exactly in between these two, as I know I've sketched the maximum value here. So it has to be here. Well, now you can join it. And this would continue on. So it looks something like that. You could find the x-intercepts by graphing and find what the x-intercepts are. You could graph it together if that helps. Or you can take the x-intercepts of the original cosine graph and multiply them by 1/2 to see what they are here. But this is just a sketch. Something like this is good enough. Example 3, write the equation of a sine function having an amplitude of 2/3 and a period of 4/6. Well, the amplitude of 2/3 is simple. It gives me the a value right there. Finding the b value is a little bit harder. So remember, the period of a graph in radians was 2 pi over b. So what I really need to solve here is pi over 6 equals 2 pi over b. So I can multiply both sides by b and then divide by pi over 6. So b equals 2 pi divided by pi over 6, which gives me 12. So one equation could be 2/3 sine 12x. Now this is not unique. We could also have negative value. So you could use -2/3 or -12 or any combination. There's really 4 possible equations here. We've got a cosine function has an amplitude of 3, so our a value is going to be 3, and a period of 720. Well, we know the period of the cosine graph is 360 divided by b. So again, I can multiply both sides by b, divide by 720, and you will get that b is equal to 1/2. So one possible equation would be this. Again, we could make a negative or the b value negative. So again, we'd have to worry about this. And we're not going to worry about c because we don't need to worry about tangent functions. For graph, consider the partial graph shown. State the amplitude and period of the graph. So remember, amplitude is half the distance from the max to the min. So half is the axis in this case. The maximum's at 3, the minimum's at -3. So the amplitude must be 3. The period here, let's see where it starts. So this starts at 0, and then it repeats here. Is where it starts to repeat. So what value is that? Well, if this is pi over 2, 1 pi over 2, this would have to be 2 pi over 2. This is 3 pi over 2. So this is simply the value of pi. So the period would be pi. Determine the equation of the sine function, which this graph represents. Well, it would be 3 sine something times x. So if we have a period of pi and we needed to go 2 pi divided by b, it should be pretty clear that b must have been 2. Last example, example 5. The graph represents the effects of tides on mean sea level over a 24-hour period. The graph is the equation h of t equals a times the cos of bt, where t is in hours and h is in height in meters, relative to the mean sea level. Determine the equation of the graph. Okay, so this is a cosine graph now. So again, we just need to find the amplitude and the period to figure this out. So we have an amplitude. Well, it looks like our max is 4 and our min is -4. So that tells us our amplitude is going to be 4. Now, the period is a little bit trickier. Whenever we're given application questions, we're always going to be working in radians. So it tells us here that this is over 24 hours, and it starts to repeat right here. So this would be at 12 hours. So if our period is 12, oops, this needs to be 2. We need to find our b value by going 2 pi over b. So I can multiply both sides by b. That gives me 12b equals 2 pi, and divide by 12. So this gives me a b value of pi over 6. Remember, this is just a number. So yes, sometimes we use pi over 6 to represent an angle, but it's really just a number. Pretty close to 1/2 because pi is 3.14. So now I can go to the function, and I have this. Y equals 4 times the cos of pi over 6 times t. So whenever we're given an application question, make sure your calculator's in radian mode and your brain is in radian mode so that we know that we're using 2 pi, not 360 here.